Just practice breaking out the composite function. It's this piece of paper that's got the girl from Swing Out Sister on it. So what was her song again? Break out. Oh, anyway, that's why she's on there. So by breaking out the composite function, I mean the question would be that you are already given the composite function and you're given just one of the original functions, and they want you to work out what the other original function would be. So they've told us f of g of x is this and f of x is that. What do you think they want us to find? G of x, yeah. So in this case the instruction would be find g of x. So by breaking out the composite, I mean the question would already give you the answer to the composite function and only one of the original ones, and you're asked to work out what the other original one was. In this case, the other original one would have to be the g of x. So there are two strategies you can use for this. This first strategy is the one which is what I did with you in the composite function notes. So we'll just go over it again quickly. And on the next page is the alternative strategy I was talking about, where if you were having trouble just looking at it and working it out by just looking at it, then there's an alternative strategy on the next page which is more systematic, where you just follow a procedure and then you find it. So, for example, let's say here's our little composite function. That's our composite. F of g of x equals 3x plus 4. So which one is the parent function, the mother? F of x, yep. And which one is the baby function? G of x. I don't know if it's called the baby function, I just made that up. The child function. So this one is one of the original functions. So this one would be one of the originals. Like the non-parent functions. And it was the mother, would you say? It was the parent one. So the mother. I kind of gave you the overall ones this time. I didn't give you the one that was subbed in. I gave you the parent function. But it's one of the original ones. They want us to find g of x, which is the other original function, which is the one that got subbed in to f. So g of x got subbed into f of x. So that's something you want to bear in mind. So using the strategy, just look at it as an experiment. You could just look at this and think, that looks pretty similar to f of x. So what do you think the x in the f got replaced with to make the composite function happen? Yeah, so that's one. So sometimes you can just look at it and see it. So just look at it. So therefore g of x must be 3x plus 4. Or g?
Wait, pardon?
Yeah, why is it 3x plus 4?
What did you just ask, or what did they say? Like,
So what we were asking was, if this is the composite, and that's, according to this, f is the parent function, the mother. So what function got subbed in for that to make the composite? Yeah.
Okay.
So we're trying to find out what was the g of x. Am I recording? I hope not. Yeah, good. Okay, we're recording. Yeah. So one of the original functions. So we found that g of x was 3x plus 4 just by looking at it.
What did you just say? You said you put it as x into the parent function. What got subbed into that?
Yeah, exactly. What got subbed into the parent function, like what replaced the x in the parent function to generate the composite, is what we have. That's what we mentally think about when we just do the look at an experiment kind of method. I would always suggest double check your answer by then finding this composite f of g of x using your two originals, just as a backup method, just to verify, do we get this answer? Because that's a way, if you look at it and go, yeah, I think it's that, but I'm not sure, you could do this. I'm missing a bracket there, as you can see. I missed the bracket there. Let's check our answers correct by using f of x and g of x to find f of g of x. So, f of g of x equals. So f was the square root of x. So it's going to have a big square root over it. And according to our idea, 3x plus 4 is what got subbed in. So let's replace the x that would have been here with the other function, 3x plus 4. Did it give us the same composite as we were supposed to get according to the question? Yes, we got that. So this was just checking that we were correct. Yes, we were correct. So you might just want to also highlight which part of this was the actual answer? This was the answer. So that's our answer. So we were asked to find g of x. This was just to check our answer was correct. If we subbed in the g of x into f of x, did we get the composite function? So I've said now use the same strategy, the look at and experiment method, to find f of x if this one, our composite, is that thingamajiggy, and that thingamajiggy is one of the originals. And oh, yeah, sorry, to find g of x. Yeah? Yeah, yeah. So this is kind of like what we did in the notes originally for composites. It's good to review it. But on the back page is the alternative strategy, which this one is where you just look at it and you see what makes sense. But sometimes you might get really tricky ones where it's hard to look at it. So the next page is the alternative strategy, which is more of a system. You just would then have to remember what that system was. System of steps. So here's our composite. Just reminding us how a composite looks. F of g of x. There's our composite. Here's one of the originals. In this case, I gave you the parent function again. I could have given you the one that was subbed in instead. So here's an original function. They want to know what is g of x. So change that up there to g of x. I should have typed in g of x. So they want you to think, okay, in this case I gave you the parent function. So what got subbed in for x in the parent function to generate the composite?
X over x minus 2.
Yeah, exactly, because it's still just something cubed. So you can see that g of x must have been 6 over x minus 2. So that's our answer, because if you sub that into that, you'll get the composite. And again, you can double check by finding the composite. I'm a bit lazy to do that now. So if you want, you can double check by finding f of g of x. Which is, in this case, big square root sign. No, it's not big square root, it's big cube. So it would have been the big cube. And then we're replacing x with 6 over x minus 2. Okay, and yes, it did work. Yeah. So they were pretty simple ones where it was pretty easy to look at it, but sometimes you might get some that aren't that easy to look at and work out. So the next page we're going to do these again, but using a system instead. Have any questions about this? Or anyone writing stuff down? Okay. We'll move on to the systematic one, because Paige has got to leave really soon. Strategy 2, Paige, is use the inverse. I've done this already. This is the second strategy, yeah? Oh, I'll do this really fast. I'll quickly show you the first example. Because you've probably got like 2 minutes. For example, that's a few minutes faster. For example, use the inverse and the composite. The only thing is you would have to memorize what this strategy is. For example, let's say that we want to find g of x if we know this and this, same example as before. Rather than just look at it, the alternative strategy is to use the fact that if you take the composite and sub it into the inverse of the original one you're given, it turns out you'll get the g of x. You would just have to remember what that strategy is, that's all. It's the second backup method. And
You sub the composite into what?
Yeah, sub the composite into the inverse.
Okay.
Oops.
Of
One of the original you're given. Yeah. So that is you substitute the composite function, which I did in blue and green, into the inverse of the given original. And the answer, when you do this, when you sub the composite into not that, but the inverse of that, so sub the composite into the inverse of that, it spits out the original. The only thing is you just have to remember.
It's cancelling out, basically.
Yeah, they're cancelling each other out. Yeah, exactly. So these are like kind of cancelling out the g of x. Doing this cancels out everything except the g of x. So it is a handy method when you've got some tricky ones. So let's double check that. To start with, what do you think I need to find first before I do this?
The inverse.
The inverse, yeah. So start by finding the inverse. Find f of negative So we've got y equals square root of x. So to find an inverse, what do we do first?
You switch them.
Yeah, if you switch them around, x equals square root of y. So what's our y got to equal? If we make y the subject, yep. So x squared equals y. And remember in the exams, had they like you to write your final answer? Like rather than... Yeah, that's right. Just reminding you in the exam, they like you to do this last step. Because technically it's not y. Y was this thing. Technically it's the inverse of y. Inverse of y. F of x. And then what we do is this bizzo. The inverse is the parent function. So the inverse will be the parent. There you need to go. The inverse will be the parent, and we now need to sub in the composite into that. Have fun. So we now find the f of negative 1, f of negative 1 of the composite. So the composite goes in here. So that composite gets subbed into the inverse. What was the composite? It was f of g of x, wasn't it? That's my letters down the right way. And there you go. So we sub composite, which is up here somewhere. Composite is square root of 3x plus 4. And then the parent function is a square. So it's kind of like if you want a big bracket with a square. And then we sub the composite in there. So the composite was square root of 3x plus 4, wasn't it? Then you just try to simplify that. Do you see it all? Yeah, because the square root and the square cancel out, yeah. So this therefore equals g of x, by the way, because that thing equals g of x.
So you have to put that x squared equals 3x plus 4, because x squared is the inverse.
Oh yeah, the x squared
is the bunch of steps, I think.
Yeah, so the x squared is a parent function. So that's why I realized that this x is going to get replaced with something. So I just opened up a big bracket and popped a square there.
Why is it square root 3? Is it just 3 4?
Oh yeah, sorry. Yeah, you're right. 3x plus 4, yeah. And so I might want to put a little step. G of x equals that thing there. F of minus 1. Just to explain why we're doing that. Okay. So just at the beginning, just reminding you what it says above, that the composite subbed into the inverse equals g of x. Means the f and the functions and the f and the inverse get cancelled out. And we're left with just g of x. So that's our answer. So this might be a nice alternative strategy when you get some tricky ones. And we already know from the previous page that that's the answer. That's correct. We haven't bothered to check it. We can now try to use the same strategy for the same example we did below. See if it works. I don't think a textbook teaches you this method either. I don't think it's in your textbook. I couldn't find it in there. That's why I thought I'd better give you a note on it. So this business, what do we need to find first? The inverse, yeah. Yes. So find f of minus 1 x first. So we go, original one is y. Y equals x cubed. What will be the in these cases? Let's swap the x and y around first. X equals y cubed. So what will our inverse function be? Yeah, cube root of x. So we write x minus 1 x. reminding us that g of x equals f of minus 1, and it's going to be a cube root, and we're going to replace the x with the composite. So I set up a, sorry, I need to do this first. This is the composite, f, and the composite was f of g of x, not g of f of x. Now we can start to do that. Equals f
Wait,
of
Miss
minus,
Elaine,
yeah.
doesn't that count? Never mind.
Yeah, so this is just reminding us the thing that was at the top of the page, that a way of finding g of x is you sub the composite into the inverse of the other original.
You sub the composite
Yeah.
into the inverse of the original.
Yeah, and that's going to spit out g of x. Because in a way, the f minus 1 and the f are going to cancel out. It's a way of cancelling out the f's. And so our inverse, that is the parent in this case, so it's a big cube root. So I set up a big cube root, so now I'm going to sub in a function in there. So give a bit of space to do that. And f of g of x is given in the question. It was this one here.
Oh, I think I get it now. So you basically just sub in you sub in the composite where x is.
Yeah, that's right. Yeah, so composite. This is a good way of kind of revising inverse and composite functions a bit too. So I thought it was a good one. So yeah, so you replace the x in the inverse function with the composite, and then you simplify. So what do you think that thing is going to simplify to?
3.
Yeah.
Equals 2.
Oh yeah, it's meant to be a 2. Sorry. Yeah, you're right. So we've got our g of x.
I said I could tell you 4 as well. And that should not misread me, just
Yeah, so that's handy for when you get some trickier ones where you're just looking at it's kind of not working for you. You just don't have to remember this strategy, that's all. You just have to remember what it is. I think we're done.
We're not.